Sands of Time is a lab and activity that allows students to play around with and get a better understanding of the law of superposition and how we relative date rocks, which will help students better understand how we get our geologic time scale. And so this can be a very difficult concept for students to understand. So I like to begin with something that's completely not science related or not concept related. So typically when my students come into my classroom on the days that we're doing this activity, I'll have pictures of people of different ages cut up for each group of students. And we'll begin the class by allowing them to do a sort. So you can see here in this PowerPoint, there are pictures that are of boys or males at different ages. And even though the students aren't going to know the exact ages of the people pictured, they can very easily tell which one is the youngest, which one's the oldest, and where they fall in between. So that helps students to understand that even though we don't know their exact ages, we know that the baby's the youngest, and then the boy, and then the young man, and the elderly man. This is what we call relative dating. It's how one object's age relates to another object's age. And this is how we date rocks. And then if we were to know the exact age of, say, this boy right here, then I now know, if I know that this boy is 8 years old, I know that this baby is younger than 8 years old and that this man is older than 8 years old. So I can start getting more exact with the dates of the unknown rocks. Then, to continue with understanding this phenomena in a safe way, I have my students look at either a pizza or this is a sandwich to help them understand how layers form. So when you're making a sandwich, I can't start with the cucumbers first. If this is the sandwich that I want to make for lunch, the first thing I have to lay down is the napkin. And then I'm going to put down a piece of bread, and then the lettuce, and then the meat, and then the cheese, and so forth. So this helps students to understand that even though it may only take me a couple of minutes to make this sandwich, I know that the bread on the bottom is older than the tomatoes, and that the meat was placed down before the cheese. So this helps students to better understand the law of superposition, that the things that are on the bottom layer are going to be the oldest, and then as you move up in layers, they get younger and younger. So bringing that back to what we're actually talking about, I show my students a picture of rocks where the layers are very evident, and I have my students talk about what they see in this picture that compares to the sandwich that we just looked at. So oftentimes students will notice the different colors, the stripes are very obvious, or the layers that are there. And so we compare that back to the sandwich. Okay, well, if that bottom piece of bread was laid down first, and then the lettuce, and then the meat, and then the cheese, where are the oldest rocks going to be? Where are the youngest rocks going to be? And how can we age these layers in between compared to each other? So that's going to take us into Sands of Time. And the first student sheet that they have is going to look like this one. And basically all it's asking the students to do is to start making comparisons between similar rock layers. The directions say to correlate the geologic units in the stratigraphic columns in Figure 1, draw solid lines between units of the same time period, and use the fossil and lithologic or rock type clues to determine the connections between the strata. These directions scare students. There are a lot of big words. All it's asking them to do is look at the layers of the rock and the designs that are on the rock that let us know the rock type, to make connections between them. Now, at this point, students have already learned about types of rocks. They've already learned about the rock cycle, and we've already done a web quest to learn about fossils. So we're using information that the students already know and building on it. Now, the directions say to draw lines between the rock layers that are similar. I've noticed in doing this with my students that that can be a little bit difficult to read once it's done. So instead, what I do is I have my students use color pencils or crayons or markers, and they're going to color the layers that they see that are similar. So this is one that a student did for me this past semester. And so all the rocks of the same type are the same color. And this makes it easier for the students to see. Now, we've just finished talking about fossils, so my students recognize these little shapes out to the sides as fossils, and a lot of them will note that they're seeing the same types of fossils within the same types of rocks. And once this is done, I like to let my students talk about in their groups what they're seeing here. Some of the rock layers are missing colors, or some of the columns are missing colors or rock layers. Why do you think that happened? This rock layer over here, this column has an extra layer of rock that's the same as the top. What could have caused that? And then I let them start thinking about which ones they think might be the oldest rocks, which ones might be the youngest rocks, and which ones fall in the middle. The next page that we're going to look at takes this a step further, and this can be a little bit more complicated for students. But it asks them to think about the stratigraphic principles. So once again, rocks are going to form horizontally, and the law of superposition says that the ones on the bottom are going to be the oldest, and the ones on the top are going to be the youngest. But this particular example starts blending in some unconformities. Unconformities are anything where those rules change. And so if you notice in this particular picture that we have here, there is a fault line going through it. There is also a tilt here where some of the rocks, even though they formed horizontally, are now tilted at a slant. And you can see here that we have some rock layer on the bottom that has another rock layer within it. So this is where I like to start to teach about those unconformities. So extrusions, intrusions, erosion of a rock layer that wipes a rock layer away. And so the way I do this is I have my students think back about that sandwich that we looked at earlier. If I took my sandwich and I put down the bottom piece of bread and the lettuce and the meat, and then I cut it, and then I put down the cheese and the tomato and the cucumber and the top piece of bread, is my cut going to go all the way through my sandwich? It's not. It's going to stop after the meat, but before the cheese. So looking at the sandwich, I can tell when the cut was made. The same thing happens with our fault line. Because this fault line is running through all of the rock layers, I know it has to be the youngest thing. Because it's cutting the layer on top, which is my youngest layer of rock, this fault happened after A was already formed. Another thing that we talk about is intrusions, which we've already talked about the structure of Earth's interior. And so we know that magma can come up to Earth's surface. And when it does that, it is coming up underneath the rocks that are already there. So if we look at this R layer right here, you see how you see pieces of C and B and Q that are inside of this layer? That C, B, and Q were already there. And we had magma that came up underneath. And so with that, I like to think about that sandwich. I tell my students, if I were to stick a fork through the bottom of my sandwich to hold my sandwich with, those layers that the fork is going through had to already be there before that fork could get in place. Now I could start making my sandwich and get up to, I've got the bread and the lettuce and the meat and the cheese and the tomato, and then I stick a fork through it, and then I finish off the other layers, but my fork won't be through the layers that weren't there yet. And so with this picture, we're going to have students put in order from oldest, so they're going to start at the bottom, to youngest, the layers of the rock. And I like to let mine work together in groups with this, and I do this, it's very guided because this is the first time that they've seen anything like this. So I might get them started with a few and let them work together, and then we'll go back and we'll check in, we'll discuss them along the way. But remember, the oldest layer of rock is going to be the bottom layer of rock unless we've had an intrusion. So I know that R is an intrusion because it has Q, B, and C inside of it. So then I'm going to look at my bottom layer of rock. Well, my bottom layer of rock, even though it's tilted, is going to be Q. Then my next oldest is going to be S, and then B, and then C, and then I have M and I. And if you look at my intrusion, it's coming up to I, where I have this unconformity here, this squiggly line. So I can guess that maybe that volcanic activity is what caused that uniformity. So after layer I, I'm going to have R and U, which probably also created my tilt, which is my T. Then moving up to the younger layers, I have K and F, O, and A, and then I have my fault line P that cuts through it. So for the final activity, students are going to start to piece together what they've learned from the first two, and they've got a cross section. These different columns were all taken from different locations within the same state. They were taken from New York, and they are marked with each layer with a little symbol to help you see what type of rock it is. Over here we've got gneiss and schist, granite, basalt, conglomerate, shale, limestone, and sandstone. It tells us to assume that the oldest rocks are on the bottom and the youngest ones are on the top, but you'll notice that not every column looks exactly the same. Erosion sometimes will wipe out an entire layer of rock. Sometimes there's a lack of deposition in an area, so a rock layer never forms. And so we're looking for patterns. We were wanting to take the different types of rock, there are 8, and put them in order from the one that was deposited first, so the oldest, to the youngest. And on this, I let my students decide if they want to draw the pattern or write the word, or some of the students will draw the pattern and write the word from oldest to youngest. And so with this, again, I find it very helpful if the students color code theirs. It doesn't matter what colors they use, but it does make it easier to see the similarities in the rock types than the patterns. And so I'm going to let you try this experiment, or this part of this experiment today. And so I'm going to upload, you have uploaded for you the same exact sheet, and we will see if you can put them in order from oldest to youngest. Remember that the oldest is going to be your bottom layer, the youngest is going to be your top layer, but you are going to have to compare the different columns so that you can see where some are missing layers and some have additional layers added in or extra deposition. Once this is done, there is a part 2 to this lab that has students figure out the geologic time scale and represent it with different colored sands in a tube. This is not one that I do in my classroom. It is good to have an example tube made, but it can be difficult for the kids to see it. Even having just a little video clip like the one that's posted for you in your teacher's notes for this unit and this lesson can be beneficial in just helping students to see how the different time periods and eras compare to each other in size and when they occurred. And remember, the way that scientists have figured this out is through the relative dating of rocks that you've been looking at today with Sands of Time.